Hi, 8th graders. You have a math assignment today dealing with something called the volume of prisms and cylinders. It's lesson 11-2. Please be looking at that section of text as we go through this. The one thing that you will notice today, and hopefully you might remember this from last year, as you look on page 563, it says that the formula for any of these problems today is basically volume equals capital B times H. And when it says capital B times H, they mean the area of the base times the height. Now, when that gets used in rectangular prisms, cylinders, or triangular prisms, the formula changes because each of the bases of those shapes is slightly different. So you'll notice I rewrote capital B as L times H for a rectangular prism. For a cylinder, I rewrote the capital B as pi r squared because the base of a cylinder is a circle. And I rewrote the capital B for the triangular prism as 1/2 times base times height because the base of the triangle prism is a triangle. So let's try this with probably what's the easiest one that you're going to face, although I could be wrong. Maybe you'll like a different one better. Let's imagine we had a rectangular prism, and you were told that its dimensions were as follows: 6 inches, 4 inches, and then this one right here is 2 inches, and somebody said, find the volume of that shape. Well, what is the base of that shape? The base of that shape is the part that's resting on the ground here. And that part is 6 by 2. See that? 6 by 2, the part resting on the ground. So volume equals length times width times height. The length is 6, the width is 2, and the height is 4. Make sense? The 6 and the 2. The L and the W are the area of the rectangular base. That base on the bottom is a rectangle. So in this case, 6 times 2 is 12, times 4 is 48. We get 48 cubic inches. 48 cubic inches. Why cubic? Well, when dealing with volume, volume is a measure of how much space is being taken up inside this three-dimensional figure, how much you can fit inside of it. And in this case, you could fit inside of it 48 cubic inches. In other words, 48 cubes that are each 1 inch by 1 inch by 1 inch in its dimensions. Okay, let's go on to this next one. What do we do with a cylinder? Well, no big deal. Notice the base of this cylinder is a circle. It's resting on this circle. What if I told you that the radius of this particular cylinder, the radius is 4 inches, and what if I told you that the height over here is 10 inches? Well, let's use the formula. Volume equals capital B times H. Capital B is the area of this circle down here. Area is pi r squared, so that would be volume equals pi r squared times the height, and our radius is 4, so we would be 3.14 times 4 squared, which would be 16, times the height of 10, right? So what do we got there? I don't know. I got to take 3.14 times 16. 4, 2, 8, 18, 0, 4, 1, 3, 4, 2, 1, 10, 1, 9. I get 50.24. I'm going to multiply that by 10, and when I do that, I get 502.4, and that would be cubic inches in this particular case. 502.4 cubic inches. 3.14 times the 16, 4 squared is 16, times 10. In other words, I could fit 500 cubic inches, 500 cubes that are about yay big inside of that shape, if it truly was 10 inches high and had a radius of 4. Okay, let's try the last one. Triangular prism. Notice the formula is 1/2 times base times height times the height. Now, this one sometimes gets people a little bit confused, so you really got to be careful as to how you look at this one. But let me draw it first, and then we'll talk about what I mean by that. Okay. Okay, so here are some dimensions. Right here, this line, we're going to call that 8 feet. And we're going to call this line right here 6 feet. And we're going to call this line right here 4 feet. Okay? Now, remember, this is a triangular prism. Triangular prism. So even though it's not resting on the triangle, this triangle and this triangle are the two bases of this particular shape because it is a triangular prism. This is one base and this is the other base. So we've got to take 1/2 times the, okay, notice small b. Why small b? Because now this small b represents the base of the triangular base. And the h represents the height of the triangle. Oh, I forgot something. That 6 feet should not go there. That 6 feet should go right here. I'm sorry, put it in the wrong spot. Now, if I had, let's see, 3, 4, 10 feet here. The question is, which one of these measurements, the 4, the 6, or the 10, goes in the base spot and the height spot? And then, what's this height right here? Well, that's the tricky part about this. Put your thinking caps on. Remember when we talked about areas of triangles, we defined the base and the height of a triangle as being the height is the perpendicular distance from the base to the opposite corner. And we've got that right here and right here. This is a perpendicular distance. Perpendicular means 90-degree angle going from one side to the opposite corner. So in my situation here, I'm going to write 1/2 times 4 times 6. And then the height of the entire prism, that's the 8 over here. Okay? The 10 we're not even going to use at all. Okay? The 8 is the height. This last height is the distance between the two bases. From this triangle to this triangle. That's the height of the entire prism. And we've got 1/2 times base times height here. This is the formula for the area of a triangle. So we only look at the triangle right now for this part of it. And the base is the 4 and the height is the 6. So when I solve this, what do I get? I get 12 times 8. And 12 times 8 is what? 96. And that would be cubic feet in this particular case. Okay? So those are the 3 different types of problems that you're going to be facing today. Hope this helps you, 8th graders.